Imagine Ananya wants to send a birthday gift to her friend Nisha, who lives in another city. The problem is that there is no direct road between their cities.
The gift cannot travel directly. It must pass through several intermediate cities before it can finally reach Nisha's city.
At every junction, someone must decide which road the delivery vehicle should take next, so that it moves closer to its destination.
This process of choosing a path from the sender to the receiver through intermediate points is called switching. Computer networks work in a similar way.
In many networks, the sender and receiver are not directly connected. Therefore, the information needs intermediate devices to reach its destination. When the source sends information, that data cannot simply jump directly to the destination. It must travel through an available communication path. The switch receives the data and examines its destination information. It then determines which outgoing path should carry the data forward. After selecting the appropriate path, the switch forwards the data toward the next intermediate network device. At the next switch, the same process happens again. The switch examines the destination and selects the next suitable path for the data. The process continues through the intermediate switches until the data finally reaches the intended destination computer. Therefore, switching allows data to move through intermediate network devices when a direct connection between the sender and receiver is unavailable.
The important function of switching is path selection. The network chooses an appropriate route so that information can move closer to its destination.
The selected path may contain several intermediate switches. Each switch forwards the data to the next device until it moves toward the final receiver. Switching is the process of selecting a path and forwarding data from a source to a destination through intermediate network devices. The important point is that networks can handle this communication in different ways. These different methods are called switching techniques. There are three major switching techniques: circuit switching, message switching, and packet switching. All three move information from source to destination, but they use very different methods.
To understand circuit switching,
imagine Ananya wants to travel by train from city A to city D. Before the journey begins, the railway authorities must arrange a complete route.
the route from City A through the intermediate cities to City D is dedicated to Ananya's train. The reserved track remains available exclusively for this journey. Once the route is reserved, other trains cannot use it. Even if Ananya's train temporarily stops, the reserved track remains unavailable to other trains. This is exactly how circuit switching works. Before data transmission begins, the network establishes a dedicated communication path between the sender and receiver. Circuit switching has three phases: connection setup, data transfer through the reserved path, and finally disconnection when communication ends.
Circuit switching provides continuous and predictable communication, which suits telephone calls. But bandwidth is wasted because the reserved path remains occupied during silence.
Now imagine Ananya writes a very large 100-page letter for Nisha. Instead of dividing it into smaller parts, she places the entire letter into one large parcel. The first courier office receives the complete parcel and stores it. It waits until a suitable route becomes available before forwarding the message.
When the next route becomes available, the complete parcel is forwarded to another office. That office again stores the entire parcel before forwarding it. In message switching, each network switch receives the entire message. It stores it completely, and then forwards the whole message to the next switch. Because the entire message must be stored at every intermediate switch, message switching can create significant delay. That makes it unsuitable for real-time voice or video.
In packet switching, the large message is divided into many smaller packets. Each packet receives a sequence number, so the message can be reconstructed later.
Unlike circuit switching, packets do not need one dedicated path. Different packets can travel through different available routes across the network. Packets may arrive out of order, but their sequence numbers allow the receiver to arrange them correctly and reconstruct the original message. Remember, circuit switching reserves a path, message switching stores the whole message, and packet switching divides the message into small packets that travel independently.